Now we can also talk about the column space of a matrix. Okay, in other words, take the columns and make those into individual vectors and see what they span. Well, everything we said about row spaces is also true of column spaces, and the reason is that a column space is just the row space of the transpose of the matrix. Okay, so if I want to establish anything about the column space, I just transpose the matrix and make the statement about the row space. So if the row vectors of your reduced matrix are the same as the row vectors of your original matrix, well, then the column vectors of the reduced matrix have to be the same, have to span the same space as the column vectors of your original. Okay. If I wanted to show that the column vectors, these three column vectors are spanned by these three columns, I can easily do it. Just transpose this matrix, then reduce it, and transpose it back. And we will have established it. Again, you want to think about that. I don't want to say it too explicitly. So, just think about this and how it assures you that the column space of the reduced matrix is the same as the column space of the original matrix. One other thing that needs to be said is that the column space of the matrix is not the same as its row space, but it will have the same dimension. So, just another property of row spaces and column spaces.